All right, good morning and welcome back to another video. In today's video, we're going to be looking at user-defined inputs and outputs. So we're going to ask the user for some information, and we're going to do calculations, and then we're going to learn how to display that information correctly into the command window. So let's first look here at line 23. So we're going to find the position of an object that's free falling. And I'm going to ask the user for the acceleration due to gravity. So I'm going to type G equals input, single quote, enter acceleration due to gravity, and then I left a space. So when I run this, I got to go back to the command window, and it's going to ask enter acceleration due to gravity and put 9.81, and then hit enter. Now we've stored this G as a variable. Cool. All right. What else? Let's ask T0 input and say, enter the initial time. Okay, and this time we'll say seconds. Colon, space, single quote, semicolon. And then TF input, enter the final time in seconds. Whoop. Space, and finish it off. Okay, so let's go ahead and run this. Boom. Go back here, command window, so 9.81, enter, initial time, 0, and let's do 10 seconds. Boom. Okay. So again, every time you run it, you're going to have to input all of these. Okay, now let's do a calculation. It's an analysis. So T equals, it's going to make a matrix from T0 by 0.1 to TF. So we just created a matrix. And then here is the horizontal distance, 0.5 times G times T squared. And we put the dot here just before the caret because we want each one of these squared. So 0, 0.1, 0.2, 0.3, all the way to 10. That's why we do the dot here. Otherwise, it doesn't know 100% what you're doing, okay? And then let's plot. Let's do figure 1. My keyboard. Let's plot T versus D. Let's make the line black and line width of 2. And then we'll label X label T seconds and Y label D in meters. And we're not worrying about that. Okay, so we've input, we had a calculation, and then we plotted it. Run. Here we go. So 9.81, 0, and 10. Boom. Give it a second, creates a plot. Look at that. Cool. And this is the horizontal distance. And again, if you move if I move my plot to a different monitor, it's much bigger. My Surface monitor, for some reason, is not cooperating very well. All right, sweet. Okay, now check this out. Say we want to find the time it took for the ball to get to 100 meters. And let's make sure we got, yeah, okay, perfect. We definitely did that. So some output options. So I'm going to write this code. Junk iLocation equals min ABS D minus 100. And I'm going to talk about this. So what we're trying to do is we're going to find the time that it took to get to 100 meters. So D, that we calculated in line 29, is a matrix. So say we subtract that matrix, which has how many? Let's see. It has 101 numbers. Okay. So if we take each one of those numbers in the matrix, so if I go to the command window and I type D, there's 101 of these numbers. So if I subtract every one of these by 100, I take the absolute value and I find the minimum number, okay, I can figure out its location in that D matrix. Okay, let's just do this. Let's see. Let's go by ones, and let's see if it's a little easier to understand. Okay, so 9.81, 0, and 10. Okay, now there is only 11 of these. So what I'm doing in this code is I'm taking 0 minus 100, 4.9 minus 100, 19.6 minus 100, 44, 78, 122, 240, okay? So each one of those numbers I'm subtracting, I'm taking an absolute value, and I'm finding the minimum. So if I type in junk now, it's 21. And I type in iLocation. Okay, so let's go back here. So junk iLocation. So the iLocation, that means it's 1, 2, 3, 4, 5. This right here, 78.48. 78.48 minus 100 gives us 21.52. And again, I took the absolute. If I take 122, subtract 625 minus 100, you get 22.625. So this is farther away from 100 than this number. Okay. So the location gives me, with that code, which number is closest to 100, and the junk gives me the difference. So it's 21. Okay. So junk, iLocation, min, ABS, D minus 100. This is a cool little shortcut, cool little feature that you can do to figure out what location. Then what you can do is you can say D iLocation equals D of iLock, and then T underscore iLock equals T of iLock. Because T is the same size matrix as D, you basically can use that to figure out what time that it took. So if I run this again, 9.81, 0, morning runner, 10. So it's within 4 seconds. If I look at my graph, I'll zoom in here. So this right here is 4 seconds. Okay. It's the closest number that we have. Yeah, it's a little hard to see, but 100's right here, but we're at like 78. Okay, boom. So 4 seconds. However, we can make this quicker by doing 0.1. So now we've got more data points, and it should be more accurate. Okay. So look, now we're at 99.326, almost 100, 4.5 seconds. So if I zoom in here, so 100 is right here, boom, extrapolate, yeah, 4.5 seconds, okay? So this is a quick little feature that you can use. So to get more accurate, let's add another 0. So 9.81, 0, 10, and it should be pretty much close, okay? Yeah, we're off by a little bit, but 4.5 seconds it's going to take to get to 100 meters. Pretty cool. Semicolon, semicolon. Okay. Now, what we can do is we can display that number correctly. So if you want it, there's a couple ways. We're going to do what we say display and then fprintf. So display, you just type display, parenthesis, bracket, and then put some text. The time for the object to fall, 100 meters is, and then put this right in. And you're going to convert the number to a string. That's how you have to do that. Okay? So now if I run it, go back here, 9.81, 0, 10, and then it will spit out the time for the object to fall, 4.52 seconds. Pretty snazzy. But now that's the appropriate way to display a number. Or you can do this. You can use fprintf, and let me make sure you can see all this. So you can use fprintf. The time for the object to fall 100 meters is, I'll talk about this number here in a second. So you had to do %f in these formatting numbers. So I'm just going to take these out for a minute. And then I'll get rid of that. And boom, we'll put a space here. And then what you're going to do here is you got to do a comma. Sorry. And you're going to put the variable name. Okay. So wherever you have %f, this variable name is going to pop right into there. So let's run it again. 9.81, 0, 10, and then boom. Okay. The time for the object to fall, 100 meters, is 4 point. Now this is crazy long. So what we can do, go back to the editor, let's delete this space, and let's put in 0.2. So the 0.2 in the decimal tells us how many decimal points. So let's run it again. 9.81, 0, 10, enter. And so we have 2 decimal places. Okay. And it will automatically format, we put 0 here, this space. But say we wanted to put, let's do 4. Okay. This is going to give us 4 characters. So let's run it again. I'll talk about it. I'll show you. Easier just to run it and show you. Okay, so 1, 2, 3, 4. So the 4, the decimal, the 5, the 2, that gives us 4. Now if we change this, say we change this to say 5, then it should move over 1 spot. Okay, see how it added a space here? Because now it's 1, 2, 3, 4, 5. Okay. Boom. So that's a formatting. So you got display, you got fprintf. All right. Cool. Okay, a couple other cool things. Say we want to display a text on the graph. So you say text, and then 5 gives us the X location. This 300 gives us the Y location, and then you can put your variable name or whatever. So let's run it again. So 9.81, 0, oh, I messed up my thumbs. 9.81, 0, 10. And then, if you look at 5, 300, so 5 is right here, it starts, and 300, it gives whatever that equation that I had. I know it's hard to see, but that's the equation that I put in there at 5, 300. And again, if your monitor probably will work better. Again, my Surface is messing up. But that's how you put a text on the graph. And then say you want to click and do it. You can actually, instead of defining an actual position, you can use what we call gtext, and it will make crosshairs that you can click anywhere. So we're going to run this again. Go back to the command window, 9.81, 0, 10, enter. And then now, make this bigger. I should have like these crosshairs. If I click, it will actually spit that equation that I wrote in GText. It's pretty cool. And there you have it. Sweet. One last thing is, say you want to click on the graph and actually get those data points. Well, you can say x comma y equals g input. So we're going to run this again one last time. Hopefully I can get these numbers to work. 0, 10. And then I'm going to first click to put the equation, and then say I click over here, boom. Okay, it should give us, here in a second, did it work? There. I think you might have to hit enter. So if I type X and Y, yeah, okay. So I clicked a bunch of times. I must have clicked this 5 times, and that will actually store. So let me run this again to make sure. So if I run it, I click 9.81, 0, 10, and I click once for the equation because that's that. And if I click one more time, left click, and then I go back to the command window and hit enter. Or maybe you have to hit enter on here. Yep, there you go. Yep. So you just have to hit enter on the graph. So one more time. Run 9.81, 0, 10. Click for the equation, and let's click up here and click enter, and then say X and Y. And those are the data points that I clicked on my graph. Okay, so that's what we have for user inputs and outputs.
Daddy.
And good luck.
Daddy.